students they have joined. It's good number, but they should be more actually. Okay. Um, yes, as you see over there, that today chapter topic is principle of sterilization and disinfection. So there are so many terms over there that make you confusion. Okay, so they are the things that sterilizations. What are the difference between the sterilizations? What are the difference between the disinfections? As you know that we used to nowadays every time using the sanitizer. What is sanitizer? Okay, there are so many things. So one by one, we will go first with the definition. Is very important. Okay, just building the concept about this chapter. So these are the objectives. First, we go with the terminology. What is that? And classification of the equipments. Okay, on the basis of the environmental risk. Then we go with the methods. We have a three methods generally: physical, chemical, and mechanical. Mostly the mechanical and the physical is the same thing, but we have the other parts over there. So we will cover this one very well, inshallah. And then impacting of the sterilizations and infection on the health as well. So for example, you are taking a too much sanitizer on your hand, applying, it will lead to causing some irritation to the skin or something else. So we will cover this thing as well. Okay, guys. So yes, see the definition. What is so we will cover this one. Cleaning, you know that. Cleaning, that you know that you have in your house, you have a Dettol, you have a yes, what is called this? There are different type of detergent in your home. If
Clorox,
even that we sorry, which one?
Clorox, chlorine.
Clorox, yes, very important. That this is the bleaching. This is a bleach. Yeah, everyone is using the Clorox. Yes, this is the bleaching. So lots of things that we have. We are applying on our floor. We have some detergent. Our mother and someone is washing the utensils, cleaning the plates and everything. So is it enough to just to wipe out the microorganism from the surface? Some microorganisms are very stubborn. Okay, they said, no, I will not go. I will stick over here. You cannot remove me with the help of this detergent and the chemicals. Some of the microorganisms, they have in endospores. You cannot kill them very easily. Later, once they go in your food chain or through the circulatory system, they're causing the many devastating problem to the human health. Okay, so we have to clean. So this is your home, this is the okay. But once you are operating the patient in the operating room, okay, you know that your patient chest is open, you are doing some operation over there. Okay, so in the environment that you know that lots of bacteria, many spores are over there scattered into the room even. So how do you save the patient? Already patient condition is very bad. Okay, he is suffering from MI, some blockage. So you are operating, so you just cleaning their heart. So how do you just to save the patient from the bacterial infection? Okay, so you must clean everything, all environment, surrounding environment, especially in the OT. You are using the scissors, forceps, you know that bacteria may be over there. So how do you clean that? Your hand. Okay, are you miss that you are wearing the mask N95? Is it enough or not? So that we will deal inshallah today. So how to limit the growth of bacteria and how would you kill the bacteria, including the endospores. So there are the some words, some definition. First you have to go through it, very important. Otherwise you will not able to just to see the concept of the chapter. Okay, that disinfection, it means that you're going to reduce, you're going to inhibit, or maybe that you are kill the bacteria. We call this disinfection. What are the means? The three things is will be happening over there: killing, inhibiting, and reducing the population of bacteria. We call it disinfection. But in the case of sterilization, as the name suggests, sterilize means sterile. Sterile, the barren means like something is not able to produce anything. We call it sterile, barren. So sterilization process, what? You are cleaning everything from the surface, means including the endospores. Endospores that you cannot remove very easily, you cannot kill them very easily because they are hard covering things. But while you are doing the sterilizations, including the virusoid, viroid, virons, prions, okay, means the protein is only the protein virus, means the protein. So including this thing, you kill everything. So we call it sterilizations. Sanitization somewhat is confusing with the disinfection. What is that? Sanitization is that you are inhibiting, you are killing from the fomite area, means from the physical area, okay, that are enough to consider as a safe by public health department or the community service. They are considered as a safe to be used by the human body. We call it sanitizations, okay, or the decontamination in the short. Sepsis, already okay, but over here we are using the antisepsis. Antisepsis is not treatment for the sepsis, septic shock disease, okay. Antisepsis is what? That you are applying some chemical onto the tissue, means something you have a bruising, cutting, okay, and you have suspect about the microflora, the bacteria living on your skin go inside you causing problem, or other microorganism in the environment. So you just apply over there and you be safe. So we call it antisepsis. Oh, screen going to slip, just wait. Okay, see, this is the antisepsis. Now, bacteriostatic and bactericidal, they are the two words again. Side means the suicide, the person who sometime they're doing the bad thing, they kill themselves. So suicide, something same thing. Side is killing. Bactericide means you are meant to kill the bacteria with the help of many chemicals. But most of the sidal effect is not apply on the endospores. So this is the important thing, guys. Bacteriostatic is what? Stat. Okay, this word is coming from static. Something is standing, something is inhibiting. Okay, means that you inhibit the growth of bacteria, but not necessary to kill them. It is not necessary because some bacteria are very smart. Okay, so you cannot kill them because some of the bacteria, especially the pseudomonas, okay, they have special proteins. I think that you have studied in the virulence factor. So they are doing the same part in antiprot same time. Okay, if you apply some drug, okay, antibiotic, they will take it, but during this process they have the special proteins. With the help of this, they vomit out, okay, they expel it out. So they have a different mechanism. Already we have studied. Sporocidal effect, yes, they kill the spores, including the endospores. Now come over here. Okay, so these are the classification of infection risk from the equipment or environmental into. So they are the Environmental Protection Act, okay, just for these things. And also we have the FDA, Food and Drug Authority, US and the Saudi Arabia. So they are regulating these things. Okay, so low risk, it means that something they are not causing the problem to human as well as like if they are not contact with the patient. Just for example, the inanimate environment, the walls, floors, ceiling, furniture, they are not directly, okay, so they are adequate, means that your chemical is not very harsh, you can easily vary in your house. This is the low risk problem. Intermediate risk, yes, equipment that does not penetrate the skin or interstitial area of the body but contact with the intact mucous membrane. So something is there, okay, like an endoscope that you are cleaning this endoscope or the bronchoscope, whatever you have, so that you are cleaning with that. Sidex is a very famous chemical. You will used to do this cleaning with the Sidex in your clinic. So these are somewhat having some risk because some chemicals are harsh, okay, they have their own actually some property that are maybe causing problem to the skin or the human body as well. So that you have to be careful about the concentration, how much the concentration. Just for example, that you have ethylene oxide is the gas, You are cleaning for the syringe, you are cleaning this one for the catheter, because you are not meant to put the catheter in the hot something for the cleaning. So we have a special method for the cleaning thing. So this ethylene oxide is a highly carcinogenic and highly exploited in nature. They will blast it something if you are putting some high concentration of ethylene oxide. So these are the things like intermediate and the high risk. So you have to be careful about this. How will you use and how much concentration is allowed? How much is tolerable for the human and how much is protecting the environment? Okay, it's very important because you have to think about the two things, patient as well as the environment, because some chemicals, example I'm giving you the bleach, you used to clean your swimming pool with the bleach. The bleach is what? Sodium hypochlorite, NaOCl, hypochlorite. And once this, and they are highly reactive, this chlorine is highly reactive, especially if somebody is draining into the water. And what the government doing in the Saudi Arabia, they have the waste management plan everywhere in the Riyadh, in all big cities. Before draining the water somewhere into the field or somewhere in the drain, final drainage, they harvest the chlorine from the wastewater and then throw the water, remaining water, into somewhere. Why they are doing these things? Because they are making that trihalomethane, and they are highly carcinogenic in nature. Highly carcinogenic in nature. It means if they come contact with our us, we will have the cancer very easily. So these things that you have to careful about everything. Not only this bleaching, lots of things. Okay, so in the bleaching, the Clorox, you should be carefully used. Okay, not like I just put the two cap of the and on the floor and start using this. No, you can apply on the floor because floor is in formite, is inanimated things, but concentration should be there. 10% maximum means you use the 90 ml of the water and 10 ml of the bleach only. Then start wiping the floor. Not directly apply the bleach on the floor. Okay, come over here. Should I? Yes, yeah, it's done. Okay, so methods of sterilization is very important, guys. Okay, so that there are the three types of sterilizations. Okay, we have the physical, chemical, and mechanical. So these are not only sterilization; they are disinfections as well. So don't confuse with the sterilization. Sterilization is completely wiping. So we have the method for sterilizations. Chemical you can sterilize, physical you can sterilize. Filtration is very important for the any drugs. Okay, just for example, the small baby, they are drinking the antibiotic. They are not chewing the tablet, and they cannot swallow the big tablet. So we used to give them syrup. Okay, the liquid antibiotic. So antibiotic should be sterilized. Otherwise, the other bacteria will be there, other bacteria, and they're causing the many problem to the child. Even with the ophthalmic drops, we used to put in our eyes. Okay, so they are the sterilized. How will you sterilize it? Will you heat it? No. Will you put some Clorox over there? No. So how will you sterilize it? We have the other filtration method. Okay, so we will deal inshallah one by one. Okay, so I think that we should better cover the condition that influence the antimicrobial agent. That I forget to mention over here the lots of things. Maybe it will come later in your slide. Maybe that we forget to put this thing. So condition is very important that influence the effectiveness of any antimicrobial agent, not only on the head. No. As I told you, just wait, just hold on. Maybe it will come later because if it is not on a slide, you will be sleeping. It's better. Now come to the physical method. So we have two types of physical method over here. Two heat method. Sorry, one is dry method and other is what? Other is moist method. Okay, so in the heat method, what exactly the principle? Sorry, what exactly the principle of this method? The principle of method is what? They are destroying the bacteria, okay, by their degrading the nucleic acid. okay, nucleic acid, and denaturing the enzymes, proteins, and what I told you, degrading the nucleic acid over here. If you see, okay, they are disrupting the membrane. Obviously, the protein is over there. They are very, very delicate. Once you increase the temperature, they will disrupt. They will have some problem over there, and degrading the nucleic acid means the DNA will be some having some problem. So obviously the DNA will be some problem. It leads to the mutation. So bacteria generation time is very, very fast. So they will start dying themselves. They will die very easily. Yes. So moisture, in the absence of moisture, high temperature required. So we call it dry heat. Dry heat is less effective than the moist heat, but even though we can do for the sterilization method. Now, I showed you these things in the lab. I was using the plastic. See over here, what is annotation? Let me use the annotation. Okay, it's not. Okay, here. See, this one I was using in the lab, okay, for taking the bacteria from the plate. That was on the plastic. And I mentioned this one, the plastic you cannot use for the many bacteria. Okay, maybe they will react with this. So we have this special type of wire we call nichrome wire. Okay, how do you sterilize? You put into onto the over this and this flame until unless it become red hot. See, it become red hot here, very, very red. Okay, see. So once you have this, okay, it means that you are meant to kill all bacteria, including the endospores, because this is a nichrome wire. So nichrome wire generally temperature is very, very high once you put under the flame. So endospores will be killed over there. So other method we have the hot oven air method. Hot oven. This is the hot oven air method. Very important. Very important for your like metal equipments like a scissors, forceps. Okay, because you are not supposed to put in the moisture heat temperature because maybe it will be corrosive. Okay, something like that you are need to sterilize the powder, some greasy material like a paraffin. We all this are using in the in apply for the patient and for the microbiological lab. So these things are very important. It needs to be sterilized before using it. So we have this method. See, 180, 170, 120, 140, 120. Okay, if you reduce the temperature by 10 degrees Celsius, see over here, 10 degrees Celsius, okay, you have to increase double of the time, 10 10 double of the time. So see, so this is the method how you use this, the oven. Come over here. Okay, now use of the oven, forceps, scissors, scalpels, swab, and the glassware that can resist the temperature at the high temperature. Scalpel, okay, scissors, swab, petri dish, some petri dish, the glass one, not the plastic one. Okay, so don't confuse over here, guys. Let me mark it. Remove it from your slide, please. Remove it. So because the petri dish nowadays we are using only the plastic one. Petri dish is not the glass one nowadays. Okay, and the flask and some pharmaceutical product as well, like a liquid paraffin powder and the greasy materials. Okay, like some oil. So we can sterilize it over here. No, once you done your operation on the patient, okay, you have done. You have a soiled cloth, you have a soil swab, and everything. So how do you discard it? In all big hospitals, they have this incineration. The temperature in the incineration is very, very high. It's not like it's burning actually. They have a special type of apparatus nowadays. This one was the old one. Okay, so over there the temperature is up to 1000 degrees Celsius. So 80 to 85% of this is destroyed over there. Okay, and you have to be actually find out which one should be go for the incineration and which one that you have sent for the higher company. Okay, they are meant to destroy these things, but for the general hospital purpose you can destroy it in this method. Okay, now this concept is very important. How do you, okay, so what is that? This is the d value, means something time value, the time required to kill 90% of the microorganism. The time required to kill, again the definition, we call this d value or the decimal reduction time value. Time required to kill 90% of microorganism, we call this d value. What is it? Z value or the z value? The time required to kill 90% of this value, and is depend on the particular temperature. Means temperature change, how much temperature changes. For example, what we did over here, see, 10 degree over here, something. So time required to kill, okay, and what is the temperature changes over there, we call it z value. So it's very important for any method, for the sterilizations, even for the disinfection. Okay, now come to the moist heat. It's very important, moist heat, because over there you can kill very easily the spores, destroy the spores even, because the moist heat is depend on the denaturation of especially the protein, because they denature the protein very easily. Okay, we have the very famous experiment, sorry, the instrument we call is autoclave. Even in the small hospitals, they used to put in the, even in the dental clinic, they have this pressure cooker like autoclave. They used to put over there all their things and they sterilize it. Okay, so there are the three things over here: the temperature below 100 degrees Celsius, temperature at 100 degrees Celsius, temperature above 100 degrees Celsius. So we have a different examples. I know that these are the very high concept over there, but you will be covered inshallah. So the temperature above, sorry, below, we call it pasteurization. Very famous, eh? Just go and open your fridge, take out the milk packet or the bottle. You will find over there, they are the pasteurized milk. What is that pasteurizations? Pasteurization, you know the name of the scientist, okay? Pasteur, father of bacteriology. Hmm? You forget him? Okay.
Yeah, Louis Pasteur, I think.
Yes. So this name is yes. Yeah. So he actually in 1867 he discovered these things. Actually, he was working that time in the wine factory. So the wine was spoiled. So this is a different story. Don't want to go into this. So he just to respect him, we call this pasteurization method. So there are two types of pasteurizations. Okay. So pasteurization is what? This is disinfection process, not sterilizations. So keep in the mind, guys. Very important concept now arises. Pasteurization is a killing method. Do not sterilize it. Means if spores would be there, you cannot remove it. So we have two methods. We call it Holder method and the flash method. Holder method name suggests something is holding. Okay, you're holding it. Means your temperature is holding. See, 30 minutes. Very easy to memorize it. 3 3 means 60-degree temperature. You put there is this apparatus over there. You put the milk over there for 30 minutes. How much temperature? 63 temperature. Flash method, like something is flash very quickly. See, only second. 72 20. Remove this 15. No need. So 72 20 seconds. So very easy to memorize it. 72 13. Then rapid cooling at 13 degrees Celsius. Rapid cooling, we call this flash method. So this is the pasteurization. We have the incipient actually. S is there, but we pronounce it zization. Inspicizations, or the instrument we call as insipator. So what is that? Over here, you are supposed to apply, or you are supposed to use for 3 consecutive days. The temperature, as I told you, should be less than 100 degree, means 80 to 85 for 30 minutes. But you have to repeat the experiment for 3 successive days. Why it is important? You know that the media, you are supposed to grow the bacteria. Your patient was suffering from tuberculosis, your PBL3. You have the Lowenstein-Jensen media, if you remember, LJ media. So LJ media is for growing of the tuberculosis bacteria. And you know that in the LJ media, this bacteria loves to eat what? Egg. You forget, So in the LJ media, egg is there. And you know that if you raise the temperature, the egg protein, okay, it will be destroyed, denature. So how the bacteria will grow on? So you should limit the temperature. So that's why we are using this method for sterilization of Lowenstein-Jensen media and Loeffler serum media for the Cyanobacteria diphtheria. So two bacteria, two media is over there. One is Lowenstein-Jensen, one is Loeffler. Okay, so L. So just you can make it easy very. This is I for incubator. Okay, and this is the L. So it's very easy to memorize. Okay. Other method is a hot water bath. Okay, special for the we call the vaccine bath. Okay, because to inactivate non-sporing bacteria for just inactivate. And attenuated vaccine that you are making or something. So we are using these things, and only some time actually is for the several successive days. It is not
Doctor,
very important for. Yeah, please go ahead.
the inspirator, is it moist heat?
No, it is not, because you are putting everything in a you are not expose the media over there. The vapor not go inside the media. It's not moist heat. You are putting the media in a very tight flask. The vapor not go inside. You are only raise the temperature for 3 successive days. Maybe some spore, something is there. It will grow, and you raise the temperature, then it will finish. Something like this. Same thing happening with the over here. The Tyndallization method is very important. The name of scientist was John Tyndall. Just to respect him, we are using this word. Okay, means the temperature is how much? No, temperature is 100 degrees Celsius. Before temperature was below. Okay, so we have different things. So with the help of this, you can kill the virus even, you can kill the other bacteria into the media, and you can also kill the spores. But how? With the help of this method. Just for example, that you have the media containing the sugar and gelatin and everything is over there. And the first day, the vegetative cell you can kill at 100 degrees Celsius. Very easy to kill. And this vegetative cell, the spores will be there. They will become again mature and become vegetative. So second day, you kill that vegetative. Still some spores are there. So after 24 hours, again become vegetative, means the normal growth. So in the third day, you completely remove all spores, all vegetative cell from the media. So this media can ready to use. Okay, now come to the steaming at the 100 degrees Celsius. Okay, at Arnold. This is called the steam sterilizer. Just ignore this thing because we are not using nowadays. Okay, just ignore this one from your slide. It's okay. Come over here. Temperature above 100 degrees Celsius. Very important. All hospitals, they have different types of autoclave. This one is for the normal laboratory. This one is the we have in our lab. This one same thing in our lab. This one you will use to see in the dental clinic. Okay, because it's very small. We call it pressure cooker autoclave. Okay, and mechanism are almost the same. See over here, guys. So they have the different system, actually the principle. What is that? They kill the spores or the vegetative cell at a certain temperature, and you apply under the certain pressure, and you are putting them into at the certain time. Okay, so these three factors you can easily kill the spores, including the spores, because the moisture heat will go inside and then they denature the protein very easily. Once the protein denature, bacteria will die immediately. Okay, so as you know that the spores. Now you can ask me why you cannot boil, because 100 degrees Celsius is enough to kill all bacteria, including the endospores. No, you cannot boil. You can boil, but you cannot kill the endospores. Yes, boiling can kill the endospores until unless you can boil for more than 3 hours. Is it possible? Not possible that you are boiling and you are consuming the time. So we have smart things nowadays. We call it autoclave. Okay, so it's depend. So don't forget this thing. 121 degrees Celsius for 15 minutes. There are some special pressure pressure I have written or not? The PSI 15. Oh, it's not. I forget to mention over here. The pressure should be also 15 PSI. Okay. So these are the mechanism how they just to go inside and create the moisture and the temperature maintenance and the pressure, very, very high pressure, they just destroy everything. So they are the things with the help of this, you can autoclave it. Okay, the all like uh, I know that it's not easy to memorize everything. So just forget it now. Okay, so just go with the principle and what are the importance. So high temperature, obviously the high pressure, so go inside very easily, and they have the latent heat. You know the heat. Sometimes the heat they have the biomass, they have some weight. We call this latent heat, m to the power l. So we call it latent heat. They have the biomass some. Okay, so there is, you know that if sometime, just for example, if sometime in your house you are boiling the water, you can dip the finger into the boiling water, you will get hurt, but you will get more hurt when the vapor is coming from there. So we call this latent heat. This is the more danger than the normal boiling water. We call it latent heat. So this is non-toxic, very fast method, least expensive, because only the instrument is expensive, but after later there is no further need money to just to do this exercise. Okay, but they have a set of disadvantages because of the high pressure and the temperature. You are not supposed to put the non-heat sensitive things over there. Okay, just go fast. To test the efficacy is very important. How do you say that this my autoclave is now working? It killed all the spores. We have the different method. You have the dark brown strip method. This strip dark brown strip method, they have spores. Once you apply on this flask or the materials that you're supposed to sterilize it, okay, they will change their color. Before it was colorless, it will become black strip. Why? Because they also have spores. These spores come into contact with the heat and pressures, they have been destroyed and their color will be changed. We call this chemical. We have the physical technique as well. Okay, you have the control timer over there, pressure over there, and temperature regulator over there. And we have also the biological techniques, very important techniques. Actually they are time consuming, because once you put this special bacteria, archaebacteria, geobacillus stereothermophilus, because they can sustain at the 125 degrees Celsius, this bacteria can easily grow over there, and they have spores. So you put the spores along with your material somewhere, not inside, and you take out this spore as well, and you grow this spore onto some specific media. If it is not growing, you can say that yes, it is sterilized. If it is growing, your product is not sterilized. So you have to repeat again. Okay, so these are the methods for checking. Radiation, two type of radiation. One is hot radiation, one is cool radiations. Okay, hot radiation because some heat is evolved from here. Okay, once you are using the ultraviolet rays. Generally that we are using in the biosafety cabinet, as I showed you, the big machine inside the lab over there. And also you can put this one in the operating room. Okay, so ultraviolet ray, you just on it, don't be there, because maybe it will damage your eyes and later it causes the, because they are mutant, because you know that how they operate, because they form the thymine dimer mutations, so it will cause the mutation to human being as well. So you have to be careful while operating the ultraviolet rays. So which ultraviolet is using, there are three types of ultraviolet, A, B, C. So generally we are using the high one, ultraviolet C over there. Okay, and we have the cold gamma radiation, all the X-ray radiation, we call it cold sterilizations. Very important nowadays, very important, because you are supposed to sterilize plastic one, syringe, catheters. okay, and other fabrics materials that you can easily sterilize with the help of the gamma radiation. Very, very famous radiation nowadays, the gamma one. Okay, because you're not, yes, one important thing, you know that this ionization usually from the radioactive compounds, but over here you are using the cobalt 60, so it's a safe to use, very safe to use, because the high electron energy transmission is coming from there, so very safe to use, no problem with the like radioactive things, because it will causing problem to the human health. See over here already I have written cobalt 60. Okay, just check your water bottle. Maybe it is near you. It is sterilized. It is disinfected. What is that? Tell me later. Eh? So how the company they sterilize the drinking water? Just tell me later. Okay. Okay. Now we have the chemical methods. We have a different chemical methods that we are supposed to use, because while operating the patient and while cleaning the floor, blood spoil floor in the operating room, how will you clean it? So we have the methods. So wide spectrum activity, yes, very fast acting, high penetrating power, obviously because they are chemicals, so easy to bind with the cell and their plasma membrane, the protein, so they can easily kill it, very easy. And they have some ranges either on the pH or on the temperature. Okay, if you want to raise the temperature, this chemical will be work more firmly, more easily, but some chemical they are inactive in the high temperature, so you have to be careful over there. Non-toxics, once you're applying on the fomites, yes, sometimes the chemicals are very toxic once you're applying on the human body. Okay, so you have to be careful which chemicals should be applied, which one is not. Some of them, they are like a chlorine, you apply it on the human body or not. No, we are applying the iodine, though they are halogens group. Okay, so we will see later over here. Okay, see, on the basis of the consistency, liquid and gaseous, we have the alcohol, we have the phenol, very famously used. Gases, formaldehyde, vapors, very important for the operating room. So we are using this VHP, vapor, formaldehyde. So we are using this one. Also the ethylene oxide is sterilization of the food product. Just go today and go to the big supermarket. How they sterilize the meat? Okay, maybe this meat is coming from Brazil, New Zealand, from India. So how they sterilize it? The government is very strict. Saudi Arabia government is very strict. They are not supposed to bring everything to this country. Okay, because they are concerned about our health. So they have this special regulation, EPA, Environmental Protection Act, and also the FDA. So how to sterilize it? You just go and check out today. Okay, so based on the mechanism of actions, okay, action on the membrane, okay, the cell membrane, plasma membrane, denaturation and proteins, oxidation is very important because we have the hydrogen peroxide and we have the halogens we are using enormously in the operating room. Alkylations, okay, and we have damage to the nucleic acid, obviously. Spectrum, yes, high level, intermediate level, low level, is depend on the which type of chemicals that you are using. As your friend said, they have the Clorox in their house. You are not supposed to wipe your skin. You cannot apply. You will have some problems. So this is a low level for the human, but the high level for the floor. So it's depend on the which area is being wiped out, either the fomite or the normal skin. Okay, see, high vegetative cell mycobacterium. So I know that this is not easy to memorize everything, but for your knowledge, you must go through it again. Once finish the chapter, which one is a high, like ethylene oxide, glutaldehyde, formaldehyde, intermediate, yes, halogens, and the low alcohol quaternary ammonium compound, because it's QAC, is very important. Okay, so I have to go fast over here. Alcohol, yes, widely used everywhere. Everywhere is using. How much? How much? 70%. Why not 100%? You can ask me the question now, doctor. That why not 100%? Just check your sanitizer. Maybe it is near you. It is showing that 70 to 75%. Why not 100% they are using? 100% is good. Absolute good, but they are not using. because you are putting the, because you, okay, because you are, you have to activate this alcohol. Activate means what? You are putting the water along with this 70%, because 70% of the alcohol, 30% of the water, means you have given them some charge. You are activate this, their activity. Otherwise it will not work. Although you are using 100%, it will not work. Okay, so what is that? We used to clean our thermometer, the patient, when you puncture. No, your patient is coming for the CBC, normal blood test. Okay, maybe some cholesterol or triglyceride or something else. So the technician will turn the blood from the skin. They apply the alcohol over there, wiping out. But the important thing is that, there's some bacteria, they are very stubborn. Okay, they are bacteroids. They are living maybe inside the skin. So that you have to be careful. Unfortunately, they are not. They're just wiping out, and they just insert the needle inside and draw the blood. Okay, that they need a special instructions. Okay. So aldehyde we have formaldehyde and glutaldehyde. Okay, very important, very important. This chemical, because they're including cleaning the spores. Formaldehyde to preserve the anatomical specimen that you are using in your anatomy lab. Just ask Dr. Juma what he's using this. He's using the formalin. Okay, that's why the very bad smell in the anatomy lab. Once you go inside. So 2%. How much? You have to be careful, as I told you. As I told you, while using the chemicals, you should be careful how much the concentration. You're not supposed to use 100% of the formaldehyde. No, you cannot. You have to be regulate their volume and the concentration. So only 2% means 98% water. Too much. Okay. So destroying the anthrax spores even. And very important for heat sensitive catheter, you can use it. Now the Cydex, very famous. I've taken this company name, the Cydex chemical name. Okay, because you will use this one in your operation theater or everywhere. Okay, because the rubber and anesthesia tube, face mask, not this type of face mask, special one, endotracheal tubes, okay, and the other methods like this one. Okay, disadvantage that they have, but you have to regulate the concentration of this. Okay, yes, phenol. You have in your home, you have the Lysol. Everyone having in their home, they have a Dettol. So how they do? They act by disruption of the membrane. Means the cell membrane will be disrupted, the protein will be exposed, and everything was exposed and die. But they are not sprocidal. They're not supposed to kill the bacteria. They having produced the endospores. Okay, some of them the skin irritants. Yes, Lysol, you're not supposed to apply the Lysol on your skin. Lysol is only for the floor. Yes, and the Dettol is somewhat is only used as a disinfectant, not for the sterilization. And the Savlon, Dettol, so these are the chemicals. Okay. Now I have to be fast. Halogens. Halogens is what? Halogens is, if you see the periodic timetable in your high school, these are the 7A group. Okay, they have the 5 things: fluorine, chlorine, iodine, and bromine, and statin, I think, isostatin. I forget. On it. So we have that iodine is very important. Okay, especially the 2% tincture. We call it tincture of the iodine. Means only few things in the 70% alcohol. Before operating the patient, you have this special swab. Okay, you just apply it thoroughly on the skin of the patient, and it is very because we call it IDO4. Okay, because they are less irritant. The very famous one, the betadine, and because they are that's it. Just go with this one. And the chlorine, the bleaching for the swimming pool. Already I have told you a story about this one. You have to be careful about environment, because this bleaching or the chlorine, Later they form with the halomethane chlorine. They are the highly carcinogenic. Okay, now the heavy metal. Heavy metal actually have the history. The people in the past, they used to use this one. Very famous one, silver nitrate. Very famous one. Okay, the newborn, the people, they used to put the silver nitrate in the eyes of the infant just to make themselves sure from the bacteria, the gonorrhea, because maybe the mother is suffering from gonorrhea because the sexually transmitted disease bacteria, they are very common bacteria. Okay, so they put this silver nitrate in the eyes because it is causing the neonatal ophthalmum, because leading that time, leading cause of blindness in the small children. But nowadays in 1960, they are, after that they are not using this one. Now we are using the erythromycin and other type of antibiotics, okay, in the neonate baby. And also we screen the mother who having the gonorrhea or not. If he's suffering from gonorrhea, we just apply the antibiotic or that's two. uh, yes. So see over here. So mercury is the actually the highly toxic. Okay, so mercury nowadays is not using. Copper sulfate is very much using in the swimming pool. You see in the swimming pool the green, we call it tahlab in Arabic. So this is the algae, blue green algae or the green algae. They form the mud. They form, we call it water blooming. So how do you kill this cyanobacteria? So we have the copper sulfate. You just clean it, and that's it. Yes, we have a dyes. You remember the crystal violet we are using in the gram staining? So what the crystal violet was doing? They're binding with the peptidoglycan layer. It means that they are disrupting this structure of the peptidoglycan. It means that the bacteria would die. That's why that we kill the bacteria before staining. So the crystal violet is binding the peptidoglycan layer. When something is you put the something chemical to the bacterial cell wall, it is binding. So it means that there is a disruptions not working properly. Okay, so we have different type of dye they are using against against the bacteria. Lithium bromide, but these are highly carcinogenic. Okay, so yeah, also using this one, especially in the PCR. You know the PCR, polymerase chain reaction. How will you see the band after doing the PCR? Nowadays we are using RT-PCR for the coronavirus, but the conventional PCR, okay, you have to see the band, where is your DNA fragments. So we put the ETBR, lithium bromide, in short, in the lab we used to call it ETBR, and it will give you the light, but it is a carcinogenic. Okay, but we are using enormously in the lab, research lab. Surfactant, yes. How will you clean out the wipe? How do you wipe out the floor, the blood stained floor in the operating room? So we have a different. So detergent is the organic organic soap. Actually, you can say that. But once the detergent is coming in contact with the soap, they will lose their power actually. So it is a very different thing. But we used to call it inorganic soap. Okay, so we have different, especially one, the quaternary ammonium compound, we call it squat. Okay, very famously used for the cleaning the skin. Applications, yes, but not for, yeah, like endospores. Hydrogen peroxide, okay, as the name suggests, you have done in the metabolism lecture. Okay, because the free radicals, they damage the DNA, obviously. Okay, so also we are using these things. Formaldehyde gas, very important for cleaning operating room free from bacteria. Okay, we use the formaldehyde gas, vapor formaldehyde gas actually, not the normal formaldehyde, we call it vapor. Now the ET oxide, okay, ethylene oxide, ETO. Why it is important? Because you have to use the plastic lenses, okay, and also like the cardiopulmonary machines, respirator, sutures, but not the cat claw. What is called it? The special sutures. What we called it? Cat claw or cat glow. Okay, I will tell you later about this. I forget the special name of sutures. These sutures you're not supposed to put over there because they have the special proteins. Okay. We have Yazid had text me? No, someone. Okay. So highly penetrating gas, but you have to be careful because they are very we call this what, if you use in the high concentration, it will be cause exploit blast. Okay, so you are not supposed to use alone, you have to put the other gas with the ethylene oxide. So over there they have the CO2. Okay, you CO2 and the ETO, they come together and they causing the sterilization method, and should be well aerated. Why well aerated? After using these things, it should be going through well aerations. It should not be there because they're highly carcinogenic. Okay. Yes, this is the VHP, the same thing, the plasma, the okay. Yazid.
Yes.
Actually, that I should be stopped here. Okay.
Okay.
Because we have only few slides. Should I continue? Only
I think
few.
we don't have a lecture, so don't worry.
Okay. Okay. Great. Because I have the appointment at 10 o'clock in the medical center. That's why.
Oh,
Okay.
okay. As you like.
Let me finish fast. Free radicals. Okay, they are depending on the free radicals that we have the ozone gas. As the name suggests, it is the oxidation process. Okay, it penetrates the membrane of the cells and damages, okay, easily generated from the oxygen. So that's why it's oxidation process. And aeration is not very important, but ozone gas, that we have to be careful while using it because they are corrosive in nature. And because as you know that we are not supposed to sterilize our rubber things, okay, so in the high heat, but they are corrosive or something, so you have to be careful over here. What is there now? Mechanical method, the filtration method, different type of filtration method. In the college that we have the filters near to the vice dean office. Okay, so how they clean the water? So they have the candle filter, a special type of glaze ceramic filter over there. We call it Chamberlain filter. Chamberlain was the name of a scientist actually. So and the Beckfield also. So just to for the respect, that's why we are using the many terms. Okay, so therefore for the purification of the water, asbestos filter. Okay, actually they are highly carcinogenic. So but nowadays the people, they are not using this one, but this is example, so I must tell you. Yes, sintered gas filter. Okay, very expensive because you are supposed to use only one time. Okay, they have a specific spores. The spore size is less than 0.2 micrometer. So it's very good to use this. But nowadays we are using the membrane filters, very famous one. Cellulose, because they have a cellulose, their size is 0.3 micrometer, and you know that the bacteria size is how much? 2 micrometer. So the bacteria will trapped over there. Okay, it's very important for parental use, means for the all type of injection, all type of ophthalmic drug like a liquid. Okay, and also for the many antibiotics, so you can purify it with the help of membrane filter. Okay, just come over here. There are some concept, actually I forget now. Okay, I forget now. Okay, if I able to recall, I will deal again in the next lecture. No, actually I tried to put the many questions over there, but inshallah in the review session, revision session, I will put the many questions and to help you in the revision. Now just tell me, the incorrect combination of temperature is mentioned for. Guys, tell me. Incorrect. Tyndallizations at 100 degree. You know this.
D.
D or C? C, the Holden method.
Yeah,
Is it?
I think it's supposed to be 73, right?
Hold on a minute.
63.
63 and I think 30.
No,
Remember
no,
this
no,
three.
wait. Yes. Actually, the Holder method is 63. Yes, the Holder method is 63, means 30 minutes. 63 means 30 minutes. 72 flash method, okay, is for 20 seconds. Okay, and later rapid cooling at 13 degrees Celsius. Hot air is used for all except rubber tube, glassware, liquid paraffin. Which one? Except hot air oven is used for what? Glassware, liquid paraffin, means the greasy other things. But you're not supposed to put the rubber tube. It will be degrade. Yeah.
Yeah.
Okay.
Yeah, of course.
Yeah. So that's it. Inshallah, I will put the many questions. Okay. It will help you in the revision, in the revision class. Okay. So inshallah. So we'll see you later.
Inshallah.
Inshallah.
Okay, guys. Inshallah, we'll see you.